looking at Chapter 2, Lesson 4 on multiplying integers out of Glencoe Accelerated Math. So far we have added and we have subtracted integers. If we add integers and the signs are the same, we add the two numbers, we keep the sign. If we add two integers and the signs are different, we subtract the two numbers and we keep the sign of the greater absolute value. If we subtract the values, we change the problem into an addition problem, and then we follow our rules of adding. So if we have to keep the first term, we change the subtraction sign to an addition sign, and we take the additive inverse of the second value, which means the opposite of that second value. Okay? We need to know those rules. Have to. But our rules of multiplying and dividing are going to be much different. The good news is that the rules of multiplying and the rules for dividing are the same. Yeah. We only need one set of rules to multiply or to divide. That's good news. All right, so we have 4 different types of problems that we could see, correct? We could have a positive times a positive. We could have a positive times a negative. We could have a negative times a positive. Or we could have a negative times a negative. Those are 4 problem types, correct? Okay? Alright. Let's kind of dot in a hypothesis. That means, what do we think they're going to be? Positive times positive. What do you think it's going to be? Positive. Okay? Alright, positive. Positive times a negative. What do you think it's going to be?
Negative. Positive.
Alright, let's take a quick vote. Winning vote is what gets put on the board. Raise your hand if you think positive. Okay, raise your hand if you think negative. Alright, we have a whole bunch thinking negative. Alright, a negative times positive. Raise your hand if you think positive. Negative. Okay. A negative times a negative. What do we think?
Negative.
And we think negative. Okay? Yes.
Is the absolute values I don't know.
Absolute value is the distance a number is away from 0.
Yeah, that's what I'm trying to say when you do positive times a negative. It would be the absolute. Absolute value.
So you think that absolute value is going to come into play here? Okay. Yes.
Wouldn't it depend on like she said, the absolute values?
Okay. Right now we're hypothesizing. Yes.
Would negative times negative be a positive?
So you think it would be a positive?
Yeah.
Okay. Your classmates voiced their opinion louder about negative, so we're going to keep it negative for now as our hypothesis. And I'll tell you what's correct in a couple minutes. Alright? So, if I had the problem 2 times 4, that means that I have 2 groups of 4, correct? Okay, so I have 4 and I have 4. That gives me how much?
8.
2 times 4 is?
8.
8. Okay, so that would be positive?
Yes.
Okay, so I'm going to change that hypothesis of positive to a positive because that one's correct. Alright? Let's say that we had a positive times a negative. So that 4 is now negative. Negative 4 is?
Positive 16.
That we're
Negative 8.
Okay, negative 8, right? Okay, so that gives us a negative. Okay, so that one is confirmed. as negative. If I had negative 2 groups, 4 groups of negative 2. How much do I have? I have negative 8. So my answer was negative. Alright, so far we're 3 for 4. We're doing pretty good. Now, those are both negative. Can I visualize a negative 4 groups? No. Alright, so if I have the opposite of those, what does that do to my negative signs? They become positive. Which means that our answer is positive. So a negative times a negative is a positive. 3 for 4 is not bad. That's 75%. Ladies and gentlemen, what we have are our rules for multiplying integers. If the signs are the same, positive and positive or negative and negative, our answer will be positive. If the signs are different, our answer will be negative. So, if we had a positive Peter and a negative Nancy, they're going to the mall. Positive Peter and a positive Peter, they're going to both have a good time, right?
Yes.
Yes, they're going to both say, oh my goodness, this was the most amazing day ever. Let's go do this again and grab some pizza later. Okay? Our positive Peters. Positive Peter, negative Nancy. Are either one of them going to have a good time?
No.
No. Neither one of them is going to have a good time. Right? They tried, instead of walking, one on the left, one on the right, they tried switching positions, opposite sides of each other. Maybe that'll work. Do they have a good time?
No.
No, they're still going to have a bad time together. Okay. If we had 2 negative Nancy's go to the mall together, are they going to have a good time?
Yes.
Yeah. So, if the signs are the same, the answer is positive. If the signs are different, the answer is negative. Okay, you have multiple ways to remember this so that we don't have to draw pictures and write out groups of everything. Does that make sense? Yes? Okay. Let's look at an example with some other numbers. So if we look in our book at example 1b, we have 4 times negative 7. Times negative 7. We know that if there's a number in front of parentheses, that means that we're going to multiply. To use our rules, we multiply the numbers and keep the sign based on our rules. So 4 times negative 7, is that going to be positive or negative?
Negative.
Negative. What's 4 times 7?
28.
28. So our answer will be negative 28. What happens if we forget our negative sign?
You're wrong. It's wrong.
It's going to be wrong. Because while it's just a little bitty symbol, positive 28 and negative 28 are very different. 28 degrees and negative 28 degrees, while both are cold, are very different temperatures. $28 and owing $28, very different. Okay? You cannot add a negative if there's not supposed to be one. We cannot forget the negative if there's supposed to be one there. Okay? This chapter is about attention to detail. Alright, questions about this example? Now we're good to go? Fantastic. Turn the page. Let's look at negative 8 times negative 14, which is example 2b. Example 2b, which is on page 72. It says negative 8 times negative 14. you, but I don't know 8 times 14 off the top of my head. Do you?
No.
No, I don't either. So let's do the multiplication longhand. Some of you might have learned lattice method. Well, lattice method has been a longer than I have been in school. When I was in school, we were not teaching lattice method. So I am not familiar with that one. We multiply old school style.
It's 112.
You have 112?
Yes, ma'am.
It tells us.
Okay. Can I show it to justify?
Yes.
Okay. And for those that don't remember how to multiply longhand? Alright, because of the commutative property, we can reverse these however we want. When we multiply, we're going to put the value with the most digits on the top row, fewest digits on the next row, so that we have less to do. That means that 14 is going to go on top, 8 goes on the bottom. We multiply. 8 times 4 is 32. We write down our 2, we carry our 3. 8 times 1 is
8.
plus 3 is
11.
okay. We end up with 112. Our answer, we have a negative and a negative, so our final answer will be positive. Questions? If you are more comfortable with a different way to multiply, feel free to use it. But remember that this is a no calculator chapter. Because the calculator your calculator knows the rules of integers. If the chapter's on the rule of integers, having a tool that knows that says that the calculator's doing the learning for you. So we are having a no calculator chapter. Okay? Other questions? Alright, I want to go through one more example with you before we try some on our own. I know, I'm just evil and being horrible. We're going to look at example 5. Negative 7a times 4b. Negative 7a negative 7a times 4b. Now, I have two terms. I have a negative and I have a positive. A negative times a positive gives me a negative. 7 times 4 is
28.
28. If you didn't know that, you could have looked right up here. A times B.
We don't know.
AB.
AB. We are not going to call it C, because C would represent its own value. So we have negative 28 AB. When we multiply with variables, multiply the coefficients first. Those are these numbers here in front of the variable. Then you multiply your variables. If we have different variables that are not the same, you cannot exchange them for a third variable. We simply put them next to each other. Okay? Questions? Yeah? Yes. Okay, so in mathematical grammar or sentence structure, you have to put a negative sign in front if it's negative. The negative sign has to go in front. Just like we put a dollar sign in the front, negative sign goes in the front. Then we would put any numbers, then our variables in alphabetical order. I am more concerned with the positive negative in the front, number then variable, than the fact that they are in alphabetical order. Okay? So if we forget that part, I'm not going to take off for it, but we need to get into that habit of writing them in alphabetical order. Just like we have to get into the habit of writing our variables in cursive, lowercase letters. Any other questions? That was a good one. All right, thank you very much.